So the videos do get long. You can fast forward in there, and you can also make it go like double speed. And I'll talk like that, right? But you can get through it quick. So if there is a section, because I'm not going to start and stop it, the videos. Like if I have you do something, then I'm just going to sit here for 5 minutes. Like you can fast forward through that, okay? Sometimes I actually am active enough to pause it, and I'll try to do that, but just because it looks like it's an hour-long video, it could still be 30 minutes of lecture, and then I had you work for 30 minutes and I didn't pause it, so figure that out, I guess. All right, let's talk about triangles, because we are going to just base the whole class off of algebra and trigonometry. We'll do the whole thing. So we'll need triangles for more than just distances. Like we're going to work with vectors, which are forces, and vectors build triangles. Your triangle strategy is going to be the same, whether it's a vector that's a force, or whether it's a vector that's a speed, or whether it's a vector that's a distance. It can be almost any kind of, we could have 400 apples and 500 apples here, right? And we could calculate the hypotenuse of apples. So triangles work with everything, not just distances. Two different kinds of triangles that we want to think about. One is this thing, which is what?
A right triangle.
Right triangle. So tell me everything you know about right triangles. What are the rules and regulations and the things we can apply to right triangles?
90-degree corner.
Yeah, 90-degree corner. Start with the simple ones. So what else do we know? This is 90, and we've got to have that, or we cannot use right triangle logic. So we want to separate these. Right triangle logic, non-right triangle logic. And we want to apply the right logic to the right triangle. All right. What else do we know about these angles?
Find them with SOHCAHTOA.
True.
Sine for
Keep it simpler, though. Just stick with angle, angle, and angle. What do we know about those angles? They equal 180. They have to sum up to 180. So just because there's one rule doesn't mean that it can't apply. Does it apply down here? Yeah, 180 degrees. So some rules do cross over, right? That one does, a really simple one, but super important. If you're given two angles, you know that angle. And I don't mean that that angle is 180. That was a bad spot to put it. But that the sum of the interior angles is 180. That's my summation sign. It's looking pretty good. All right, back to right triangles. What else do we know?
long end is the head buttons.
Yeah, so we do want a labeling structure. Like if we all label it similar, that's going to help. In the book, when we do triangles, they label it for you. But as we move along, you're going to label stuff yourself. And we do want lowercase on the side lengths, whether that's a vector or a velocity or a distance, doesn't matter. But we want these to be small lowercase and your hypotenuse to be C. Sometimes we'll make it H, sometimes we'll make it other things, but you know, most of the time it's C. And then your opposing angle is the same character in uppercase. So the angle opposite of A, and this is huge, and I don't think they teach this enough, just to identify where the angle opposite the side is. But you have to have that concept down in order for SOHCAHTOA to work, right? Where's the angle opposite this side? It's over here. And it should be labeled of the same character but capitalized. Does that make sense? All right. So then this would be C. Sometimes we don't even label that because a lot of times it's given on a right triangle, right? It's 90 degrees. And then this would be B. That sets up SOHCAHTOA. If you cannot like visually see the angle opposite, then you're not going to be able to do opposite over adjacent, right? Because it's opposite over adjacent. You have to be able to identify that. Good. What else?
3, 4, 5.
Yeah, there's some ratio triangles. I'm not a ratio guy. So if they give us ratios like this side is 4, this side is, no, 3, 4, and 5, right? Yeah, so there are ratio triangles that work out just right. I'm an angle guy where I always calculate. Even if they give me 3 and 4, I'm like, oh, I'm not going to do it. I'm going to calculate an angle and then calculate the side. Because a lot of times you have to use the ratio then to solve the problem with other numbers. It's fine if you're comfortable with that, do it. The book does it now and then, so it's a good thing to bring up. The book does do it now and then. It'll give you, instead of an angle, it'll give you a ratio to a rise and a run, which is basically giving you the angle. Okay. What else? What applies to right triangles? We've said it a few times. You've said it. I've said it. SOHCAHTOA. Right? Sine, cosine, tangent. Those functions apply to right triangles. They do not apply to non-right triangles. So the sine function, what is that? Sine of some angle is equal to opposite over the hypotenuse. So that's often how it's written, and the whole SOHCAHTOA thing is a way to remember it, right? So I think if you spell, I don't know if I'll do this right, SOHCOATOA. So sine is opposite over hypotenuse, cosine is opposite over adjacent, tangent is opposite over adjacent. That's not right. This has got to be an H. SOHCO. I never did it. I never learned that. I guess memorized sine. But sine is opposite over adjacent, or opposite over hypotenuse.
Because we have that for
Cosine is, yeah, this is wrong.
I think it's OA and then.
Yeah, so I can't even write it, yet alone remember it that way. So I don't have you memorize formulas. You'll be able to have a crib sheet on quizzes and exams, along with your book on exams. So just know where to find it, I guess, to get these relationships. But these relationships work. Andy Dryden.
Hey.
I'm going to pause for a moment and say hi to my friend Andy. How do I do that, Andy? I see it. Oh, did I not even start the recording?
You did.
Oh, thanks. All right, Andy's gone, so we can keep going. Cosine. Adjacent, ADJ over hypotenuse. And then tangent. Opposite over adjacent. So those are the primary functions for a right triangle. They will help you solve for sides or angles. Either one. You must know two of the three things. So here there's three unknowns. 1, 2, 3. Right? You've got to know two of them to run the darn equation. If you don't know two of them, you can't do it. Like, you're going to have to figure something else out. You probably have to go back to this and find another angle. Right? So it doesn't mean you can't solve the problem. It just means you don't have enough information yet. You got to know two of the three things. And you have to know your reference angle or a reference side. Like, you got to know some information. So I think where people struggle the most is when they don't have enough information, or they just don't recognize they have enough information before they can run the equation. So here, if I know like these two sides, I can get the angle, right? You have to work with what you're given. You can't just like say, I'm going to use the sine function because that one I like the most. Well, it's not going to work all the time. You have to choose based on what you know, what you solve for, okay? What else? Anything else about right triangles? We're going to practice with this stuff in a second. We got the 180 thing. We have it labeled correctly. We know the sine, cosine, tangent. Is there another equation? Yeah, so we don't even need to go there. We can do everything with these three. Yep. But there's another equation that we've already used. Pythagorean theorem. Yeah. Don't forget that one. C squared equals A squared plus B squared. That's it. There's no other ones for the right triangle. There are other triangle equations, right? Cosine law, sine law. But that's down here. This This is all we get for right triangles. Don't apply anything else. If you apply the cosine law to this, it works 75% of the time. 25% of the time, you get bogus information. Don't do it. Sine law works sometimes it doesn't. Okay? All right, let's do one of these. Here, you get a clean piece of paper and we'll actually knock a homework problem out. So we will start homework problem set 1 together and work 1 or 2. I'm gonna stop this.